Alright, welcome to video number 3. I just made this example. I have no idea if it's going to work, so let's explore it together. So, you suspect clients from recent years have more anxiety than clients from previous years. I apologize if my face is cutting off this language. You collect your patient's anxiety scores from the past 4 years and compare that to the national average score. And then I gave you the characteristics of that population, the population mean of 37, standard deviation of 2.7. Use an alpha value of 0.05. And then I gave you your 4 samples. So, how do we find whether or not our clients from recent years are more anxious than the national average? How do we find that? Okay, so the first thing that I'm going to do, just to give ourselves a roadmap, is I'm going to draw out or write out those steps. So this will let us know where we need to go. So the first step we're going to do is we are going to make our hypotheses. The second step is find the critical value. Oops. The third step is then find the test statistic. The fourth piece is make a decision. And then the fifth piece, which is kind of a bonus, is to find the effect size. The book doesn't give you this fifth bonus one, but it's an important step, so pretty much I'm always going to ask for the effect size usually. Alright, so let's go through these 5. So before we even do that, what I would like for you to do is to pause this video and try it yourself. See how far you get with each of these. Maybe skip around a little bit if you need to, and then check in and we can do it together. Alright, so I'm going to let you pause it. 3, 2, 1. Okay, so now I am going to assume that you gave it a shot, and now you want to check your answers, see if you got it right. So let's do it. So I'm going to start with the hypotheses. So I know that I have an HO, and I know that I have an HA. So I have a null hypothesis, and I have the alternative hypothesis. So where do we want to start with? I'm looking at this and I say your clients, you suspect clients from recent years that have more anxiety than clients from previous years. That sounds directional. That sounds like I'm expecting more. So what I would say then is I'm going to expect the population to be more than essentially than 37. I was debating about whether or not I should put mu2 here, so sometimes you'll see this reflected like this, but I'm not going to do it for this. I feel like it's a little bit more clear to put the actual number here, which means that again the null hypothesis is going to be the opposite of this, right? Which means that it's going to be the population mean is going to be less than or less than or equal to 37. So these are your hypotheses. So alright, we just finished the first step. How easy was that? Okay, so now finding the critical value. Now this one depends on how you want to solve this, because we know the alpha value is 0.5, or 0.05, so it's about 5%, right? So that 5% is key. Let's tab over to the z-score calculator. Alright, so I'm looking, and I'm going to pretend like I don't know what to look for. So let's say that you pull this up during exam time, you're confused, you don't know what to look for. This is why it's really helpful to draw out your curves. So if I am expecting it to be in the greater than part, right? So I'm drawing out my normal distribution. So I know that I'm looking for something in this tail over here. That I'm looking for, essentially, because it's unidirectional, that I'm looking for 5% over in this tail. So what is the z critical value that is going to tell me that this is the 5% in the extreme, and then this is the 95% everywhere else? So how do I find that value? I can start plugging in some values here. So I don't know which of these to put them in, so I'm just going to take a shot. So 0.05, remember that's my alpha level. So I'm going to hit that button there. And okay, well this doesn't really seem to be what I'm looking for either, right? Because you can see here, that looks like a huge shaded region, and I want there to be a small shaded region. So maybe I should put this down here at 0.05 here. Will that get me closer to what I'm looking for? And indeed it does. It looks like this is 5%, just like I confirmed by drawing it out, so I know I'm on the right track now. So what is that Z critical? It's Z equals 1.645. That's why I mentioned it may be familiar, because we've been using the alpha value of 5%, you know, in our examples. So 1.645 is what I want to use. So my critical then is going to be positive 1.645. And you can round that up if you want to 1.65. All right, we're making good progress. I'm feeling good about this. Now, what's the test statistic? All right, let me write out that formula just to remind ourselves. And I'm checking, and oh yeah, remember that basically we looked at this in terms of the year. Sorry, not the year, but by year, by sampling for each year. So Z is going to be equal to, I'm going to throw in my sample here, subtract from that the population, divide that by the standard deviation, but returning that, remember, into the standard error. So that's what we're going for now. So we want to try to find this. How do we find that? We can just plug in those values because we already have all those values. So what is X bar? X bar, we just gotta have to find the mean of this, and we can do that no sweat, right? That's some old chapter 3 stuff right there. So actually I was gonna pull out a calculator, but come on, it's just, I can do this. I have to do this in front of you, just so you know that I can actually add things without a calculator. Alright, so that's going to be 4, so that's 12, plus that is 7, 170 divided by 4. That's going to give me, oh, nice round number, 15, wait, no, that's not, 45, sorry. I almost messed that up pretty badly, but yeah, that's 45. So, and wait, no, it's not. Don't pay me any attention. That's not right. That should be 1 and 0. I don't know why I put 4 there. I just made this. I got into my head. I psyched myself out about this stuff. So it's actually 42.5 if I had to guess, right? Because out of 10, I'm going to divide that by 2. It's going to give me 2, 0. Yep. So 42.5. So that means that our sample mean here is 42.5. I'm going to subtract from that the population mean. I already know what that is. It's 37. I'm going to divide that by the standard deviation, which is 2.7. And I'm going to divide that by the square root of n. What is n? Remember I have 4 samples. 1, 2, 3, 4. So it's going to be 4 there. All right. And I already know the square root of 4 is 2. So I could just put that in. But one thing at a time. Let's do this. All right, so 42.5 subtracted by 37 is going to be 5.5. I'm going to divide that by 2.7 divided by the square root of 4, which is 2. So that's going to be 5.5 divided by 2.7 divided by 2, which is 1.35. And so now 5.5 divided by 1.35 is going to give me 4.07. So that is my Z obtained. So that is the Z score that I'm going to be using as my test statistic, 4.07. And now it's time to make a decision. So what do? Do we reject the null or fail to reject the null? What do we do about this null hypothesis? So one way to interpret this, I'm going to draw out my curve here. Imagine that this is the the population's anxiety, and so we got 37 here, and we know that the critical value here is going to be 1.65. So if this was, we could think of this as like, this is a z-score of 1, and this is a z-score of 2 over here, right? So z-score of -1, a z-score of -2. So what this is showing us is that essentially we just need our z-score to be beyond this. It needs to be further over here into where we expect it to be. Is a z-score of 4.07 greater than that? You are absolutely correct. It is. It's like way out over here, right? So it's definitely significant, which means that we can reject the null. So what the hell does that mean in plain English? Basically, it means that our clients do seem to be more anxious. That we ran a test on it and we found that they are more anxious compared to the national average, which means, thinking broadly again, that our sample is not actually part of this population. That it comes from a totally different part of our population, that these two cannot quite be compared, which means that maybe our clients need some kind of special intervention or special treatment because we know they are high anxiety individuals. All right, now the last thing that I want to do here is I want to find the effect size, and this will be pretty easy, I think, because it's kind of like finding the test statistic for z-scores. For t-scores, later in future chapters, it's not going to be the same. But for now, it's going to be pretty easy because we know that to find Cohen's d, all we have to do is subtract the sample mean from the population mean, then divide by the standard deviation. So when I plug those values in, it's going to give me 42.5 subtracted by 37 divided by standard deviation, which is 2.7. And that's going to give me 5.5 divided by 2.7. Which means that my effect size is 2.04 when I round up. So 2.04 is what my Cohen's d is. So what does that mean again in plain English? Basically it means that not only are our clients experiencing more anxiety in recent years compared to the national average, but they're doing it by a pretty wide margin. That this right here is a pretty high magnitude. It means that they are 2 standard deviations above where we'd expect them to be, which is huge. Yeah, so that's how to interpret that. All right, I think that's pretty much it. But if you have any questions about how to get any of these numbers or what I did, or maybe better yet, if you notice that I screwed up somewhere, that's my worst nightmare, is that I've made a mistake on here and that somebody finds out and emails me. But if you find that, let me know because I want to correct it ASAP. But I think that this checks out. I could throw it into JASP if I wanted to. And that's always one way to check your answers, just throw this stuff into JASP. But yeah, so that's how to go from starting from scratch, how to solve one of these, something you can probably expect to find on the exam. Thank you so much for tuning in. It is about 1 o'clock in the morning now, so I'm going to go to bed after I upload this. Thanks for tuning in. Hopefully it's not 1 a.m. where you are. I will see you later.